Okay, good afternoon, everyone. My name is Sabrina Kofer, and on behalf of Choice and ACRL, I'd like to welcome you to today's program, Redefining Research, Uncovering Climate Impact Insights with Digitized Primary Sources, which is sponsored by AM. This session is one in a series of sponsored webinars from Choice and ACRL that addresses new ideas and developments of interest to the academic library community. I'll just put a couple links in the chat where you can register for upcoming webinars and watch previous webinar recordings. Before we get started, I'd like to point out just a few features of the webinar software. All attendees who join the presentation are automatically muted and your cameras are off, so don't worry about generating any noise or feedback. We've got that taken care of for you. In the main area of the screen, you can follow along with the presentation materials. To adjust the size of the slides or video, you can use the divider in the middle of the screen to slide the sizes to your liking. We are using the Q&A feature today. Please use it to ask questions of our speakers. We'll answer as many questions as we have time for at the end of the presentation, so please do type your questions into the Q&A module as they occur to you. Also, there's closed captioning available for today's session. To toggle the automated captions on or off, please use the CC button on the bottom panel of your screen. Last, please note that we are recording today's program and everyone who registered should receive a follow-up email with a link to the archive version. And with that, we are ready to get started, so I will hand it over to Laura.
Great. Thank you so much, Sabrina, and thank you for everyone who's joining us live from various parts of the world. Thank you so much for making the time to join us today. And also, I just want to take a moment to thank Sabrina and Ashley from Choice, who've done a lot of hard work behind the scenes to make this webinar possible, and also my colleagues Lucy and Abby, who you won't hear from, but they're behind the scenes and have done a lot of hard work to put this webinar together. So I just want to take a moment to thank all of the work that they have done. So we're kind of gathered here today to talk about climate impact insights using archival sources. And we're really lucky to have two amazing speakers who've done really exciting research using archival sources into climate and weather events. And I will hand over to them soon. I'm sure everyone's here to hear what they have to say. But I was just going to take a few minutes to kind of introduce AM and what we do, and the idea of weather in archives and how that might impact the publication of archival sources before we get into their kind of more in-depth insights into the kinds of research that can be done with archival sources. So my first ever experience archiving happened when I was an undergraduate student. I was just going from my second year to my third year, and I stayed at my university over the summer. And luckily, whilst I happened to be there, the poet Ted Hughes' sister, Alwyn Hughes, decided to donate a few boxes of Ted Hughes's archival material to the college. And since I was there over the summer, I was asked if I wanted to go through those boxes and see what personal papers he had and to catalogue them. And that was my first kind of experience of being in archives. But then one day towards the end of the summer, I'd almost finished this archiving job, and I came back on Monday back to work, and I heard from the librarian that all of the librarians had been called in an emergency call on a Sunday morning to go back to work. And I asked her what had happened, and it was to do with the rain. So it had been raining through all of the weekend to the extent that it had been categorized as a flash flood, and all of the librarians at the university had been called in a kind of sudden panic to come and rescue archival materials and books that were maybe not being kept in the best of conditions. Cambridge University is kind of full of very medieval buildings which were not originally built to preserve the best kinds of we're not built with the idea of kind of preserving archives. So there was a kind of sudden flurry of librarians who came back to work on that day to kind of rescue all of this material. And That was kind of really my first kind of encounter with archives, and in some ways, the relationship between archives and weather is kind of a very fundamental one. So it's something that goes really into the essence of it, both practically and conceptually, in terms of archives wanting to create these environments of perfect preservation. And I've listed a few of those things that are kind of often controlled within archival spaces, things from the relative humidity range to the temperature range in the archive, ventilation to avoid stagnant air and mold from gathering or dust from gathering in the papers, and limiting exposure to both natural and artificial light. And in AM, or some of you may have known us before as Adam Matthew, we have been working with archives for 35 years. So it's kind of our specialism to work with archives around the world to digitize their rare and unique collections and make them available online, so that, I've put some pictures of the British Library and the India Office records, which we've been working on for a long time. So you can then access them on your laptop, whether you're in Quebec or you're in Seattle or any other part of the world that many of the attendees here, where you're coming from today, are able to then kind of access and look at those records through your library's access. And each of the item that we digitize is inspected for conservation needs, and we work with trained conservators for each project, covering all of the cost of this work, to ensure that all of the items are in a fit condition to be digitized. So for example, with the India Office records, which are kind of a mammoth set of records within the British Library, there's a half a dozen archivists working full-time around the year doing conservation work on that material. And in some ways, we're also part of that kind of preservation journey for those records. So even if you're a researcher and you travel to London to visit the British Library, often you're kind of encouraged within the reading room to access the material within the database, so that can minimize the amount of time that those records are brought from, where they're being preserved and held and handled less by human beings. So it's a kind of an enormous privilege, I think, as a publisher, to be in this space of working with this kind of really rare and unique material, and to play a part in their preservation and making them kind of accessible to a wider audience in a sustainable way, and breathing life into them in different ways in the digital space. But if there are archives in weather, there's also weather in archives. And we will hear very soon more about the detailed research methodologies from Philip's and Brian's papers that can be used within archives to do climate research. But I wanted to pick out just a few of my own highlights from other collections before handing over to them that we've published. So there's a kind of huge range of different sources that shed different light in climate and weather. On this kind of slide, you can see a visual source. So this is a first-hand image painted of a weather event, a painting of a typhoon in the China Sea from 1844 that was painted by someone who was there firsthand to witness it. I've also included on this slide kind of example of a directive from our Mass Observation Project database, which sends out surveys twice a year to a kind of a number of everyday ordinary people living around the United Kingdom, asking them various open-ended questions, and it can be quite eclectic. So you can see, for example, on this directive on this slide, there's the first question is on public library buildings, and asking people their experiences and memories and the ways in which they use public libraries in their life. And then the next section relates to hurricanes in the USA. So that was the year of Hurricane Katrina, and the people who were answering those surveys were asked to kind of reflect on what that meant to them. And what's really kind of special about those surveys and people's responses to those surveys is the kind of huge range of different voices and opinions. It's not a monolithic kind of perspective on that event that comes through. It's very varied. So there's, for example, a woman in her 70s who lives in London, and she says, I was amazed at how accurately meteorologists were able to forecast the path of the hurricane and marveled at the satellite images which we saw on TV. The severity of this year's hurricane should leave no one in doubt that world weather patterns are changing and that the speed of global warming may be greater than expected. Forecasters here have often predicted that we are likely to experience more extreme weather conditions, drier and hotter summers, and more severe storms. Then there's another man who's also in his 70s and doesn't actually live too far away from London. He lives in Tunbridge Wells in Kent, but he has a slightly different take. So he writes that I am afraid that my immediate reaction to the hurricanes was a feeling of déjà vu. We had been there before, and we will certainly be there again. Were the hurricanes a direct result of global warming? Many people seem to think that they are. Yet there have been hurricanes in the Caribbean since weather records began, and it is yet to be established that the recent hurricanes were significantly worse than the others that occurred many years ago. And we'll hear a bit more about weather events in the Caribbean in Brian's paper. But there's then the final response that I'd give you, just to give a kind of slightly different take on that, is from a woman who's a lot younger. She's in her 30s and she lives on Isle of Man, kind of small island in the Irish Sea. And she said in response to the question that all of those who are in our 20s and 30s have noticed the more extreme weather and the moving of the seasons. We look back with nostalgia to the time when the autumn harvest festivals at church actually coincided with the harvest instead of being up to 6 weeks late. Where I live these past 12 months alone have seen a great storm which caused much structural damage. Bulbs came up in November, cherry trees blossomed in December, no summer to speak of, and the warmest October day on record. The UK has just been hit by unusually early snowfalls, causing chaos as usual. So that's kind of just a small range of the different responses. There's kind of hundreds of different responses to these, and these are something that have been mapped through various surveys over the years, not just in response to Hurricane Katrina. There are kind of number of different weather and climate kind of questionnaires over the years, from like the 80s to the 2010s, included in the collection. In addition to that, there's also, I thought, as a final example, before I hand over to Philip, I just want to mention, in addition to these surveys and these visual images, there's also quite detailed weather logs in collections like Life at Sea. So these are different historical weather data that comes from the Life at Sea collection. So you can see a travel diary from John Barker, who's headed on a ship from Boston to San Francisco in 1849, 1850. And I've run a search for the word weather within his diary, and because we have handwritten text recognition program applied to it, you can get search results for the word weather, and he's reflecting on the different kind of weather within that journal, and also giving quite detailed latitudes and longitudes at the end of each of the passage, so you can give the date and the exact location for his reports. And there's another one that's a log of a ship called recovery from 1816 to 1817. And that's from a ship that's headed from Boston to Calcutta. And you can see that this is kind of the person who's been writing that log has actually kind of drawn different columns in order to give different kinds of data. So there is a kind of textual weather information where he's talking about what the wind feels like and what the weather feels like and looks like. But he's also giving kind of longitude and latitude information, distances in numbers, and different kind of wind speed measurements. So there's a kind of a more detailed historical weather data involved in various collections as well. And we'll hear a lot more about how those can be used in depth in research to make different kind of research insights and change how we view the historical climate in Philip's and Brian's papers. And I'm going to kind of hand over to Philip now, just to introduce him. Philip Gooding earned his PhD in history from SOAS, University of London in 2017, and he's a project manager at the Indian Ocean World Centre in McGill University. He's the author of On the Frontiers of the Indian Ocean World, A History of Lake Tanganyika, circa 1830 to 1890, which came out with Cambridge University Press in 2022, and editor of Droughts, Floods and Global Climatic Anomalies in the Indian Ocean World, which came out with Palgrave Macmillan in 2022. He's also published several peer-reviewed journal articles included in Climate of the Past, the Journal of Southern African Studies, and the Journal of Interdisciplinary History, and he's the associate editor of the Journal of Indian Ocean World Studies. So over to you, Philip.
Thank you very much, Laura. All right. So I'm really going to talk about climate modeling and how that relates to historical archives. So this is kind of a combination between the disciplines of climate modeling, which is part of climatology, and history, which is, as Laura said, forms the basis or the core of my training as a doctoral student and then my academic appointments afterwards. So I'm going to start with a very broad statement. And that statement is that climate change is currently the major challenge facing humankind. This is driven by global warming, particularly in the last 250 years, which has been triggered by heightened greenhouse gas emissions, anthropogenic greenhouse gas emissions. Understanding climate change, what it's going to do to regional climates and to states and societies is something that we're still learning about and modeling. One of the major questions is how do changes in global temperature affect regional climates? So we're talking about from the global to a much more regional perspective, and how will it not just affect temperature in those locales, but how will changing global temperature affect phenomena such as wind and rainfall? And these are still very much under investigation. Our understanding of kind of how regional climates will vary or change as a result of global warming is continually being refined. And the extent of our knowledge varies according to which region you're looking at. My archival research seeks to enhance the certainty of climate models that project future climate conditions. And I'm doing this in conjunction with climatologist colleagues by trying to improve the accuracy of reconstructions of past climatic conditions on which the models are based. So that is trying to understand past climatic conditions, so reconstructing past climates, past rainfall conditions, and then that can be the basis on which models that project the future climate conditions can be projected. I'm going to start by showing kind of why this is kind of an important endeavor, and I'm going to show that by and I'm going to start by showing you this map. This map is a map of the world. It has just just under 3,000 points in it. Each of these points represents a locale where natural scientists in the discipline, for example, of paleoclimatology and dendrochronology have analyzed a natural proxy source. Now, what is a natural proxy source? Well, a natural proxy source is something like tree rings, which form the majority of the points in North America and Europe. Corals, which are most of those that are in the ocean, and ice cores, which are most of those that are in Antarctica, in the Andes Mountains, in South America here, and in Greenland. And by chemically analyzing and observing these different natural proxies, climatologists are able to reconstruct past climatic conditions in those locales. Now, this is a map of all of those studies that have been recently integrated into a global climatic model, which pertains to reconstruct climatic conditions over the entirety of the globe, from the period 0 CE to the present day. So just over 2,000 years. It's an amazing effort. And is a significant contribution. The data set itself was published in the most prestigious natural science journals, including in Nature. But as you can see from this map as well, is that all of these, that there are significant gaps in them as well. You will note that most of the points, and most of this climatological research into tree rings, ice cores, and corals has taken place in the global north, especially in Europe and North America. Now, this is a major problem for two reasons, or it's a major challenge for two reasons. Firstly, in terms of methodology. So this model, which incorporates all this data, pertains to reconstruct climatic conditions over the entirety of the globe. But for the global north, for North America and Europe, this is based largely on data from the region. Whereas for places like much of South America and Africa and the Middle East and South Asia, it is based on modeled data. Therefore, we have a lot more certainty for its reconstruction of climatic conditions over the global north than over most of the global south. Now, the other challenge with this is I think that provokes some ethical challenges as well. This means that we have the least certainty about past climatic conditions over regions that also happen to be the most vulnerable to the effects of global warming. Many of these regions have highly seasonal rainfall regimes, and we need to know about the seasonality we need to know more about how seasonality has been and will be affected by changes in global temperatures moving forwards. In addition to that, most of the countries in these regions have the least economic capacity to build effective mitigative strategies against the effects of global warming. Therefore, we know most about how global temperature changes interacts with regional climates in temperate climates, and less so in highly seasonal tropical climates as well. Therefore, there is a need to enhance knowledge about past climatic conditions in many regions of the global south to improve understandings about the effects of global warming and to develop strategies that can mitigate its effects. And this is kind of where my research is situated using historical documents. So, as mentioned, I was trained as a historian. And during my research for my doctoral program, which was focused on the history of 19th century Eastern Africa, especially Tanzania, I discovered that many of the archives and the archival materials I consulted contained climate data. Now, which archives am I talking about here? I'm talking about the letters written by missionaries, so European missionaries, who traveled to and lived in Eastern Africa in the 1870s to 1890s. And their letters, which they sent from Eastern Africa to their head offices in London and in Rome, are among the earliest documentary traces that refer to inland regions of present-day Tanzania, Kenya, and Uganda. Missionaries were there to spread the gospel. That was their core aim. but they reported on a wide variety of phenomena. Apart from as missionaries, they saw themselves as amateur ethnographers, as anthropologists, and also as natural scientists. They thus also reported on climatic conditions. And I want to give you an example here. Now, the image of this letter I've posted on the right here. This is a letter that was written by a missionary called Edward John Baxter. He was a Protestant missionary of the Church Missionary Society, and he wrote this letter on the 21st of February, 1880, from a town called Mpwapwa, which is here about 200 kilometers or 250 kilometers from present-day Tanzania's eastern coastline. And in this letter, which contains a wealth of information, it contains information about his relationship with his colleagues, about construction on a school, about church services, the kind of things that he might be expected to read in missionary correspondence. But he opens it here on the first page with this extract here. It says, "Just a line to let you know we are all well. This wet season has been extremely dry, so that there is great scarcity of food. Until the latter end of last week, we have had no rain here, excepting the few showers which fell in November and December, which we thought were the commencement of the rainy season. Everything appeared to be scorched up, or nearly, so much of our land has had to be resown." Okay, so this letter was written in mid-February. Now, we now know from over a century's worth of observations that the rainy season in Mpwapwa normally starts in December. Thus, this letter indicates that the rains have not come even 2 months into what would normally be the rainy season. Additionally, the rainy season in Mpwapwa lasts until the end of April and the beginning of May. Now, subsequent letters, which I'm not going to show you here due to lack of time, show actually that the rains were weak for the remainder of the season as well. And this contributed to major harvest short, like the harvest was much weaker than normal, and this contributed to much hardship in 1880. Essentially, the 1879, the missionary correspondence suggests very strongly, and by direct references to climatic conditions, that the rainy season in 1879 to 80 was very weak, and that there are significantly deficient levels of rainfall compared to normal. Now, this letter is stored, the original of this letter is stored at the Cadbury Library at the University of Birmingham in the UK, along with all the other letters of the Church Missionary Society missionaries who are located not just in Eastern Africa, but also in China, the Middle East, and South Asia, among other places as well. And the Cadbury Library at the University of Birmingham basically stores the entirety of the Church Missionary Society archive. Now, the majority of this archive has now been digitized, and it is made available via subscription to AM, which is how I accessed it at my institution here in Montreal. So one of the major aims of my research was to collect and standardize not just this report from 1879 to 80, but also all references to climate in the missionary archives related to Eastern Africa in the 19th century. This meant looking at the archives, not just of the Church Missionary Society, but also of the London Missionary Society, which is stored in London in the basement of SOAS, where I did my doctoral program, and also the archives of the White Fathers, which are just out the back of the Vatican in Rome. I did this, and then this kind of image here, this graph, is what that ended up looking like. How was this graph created? Well, by looking at all the qualitative descriptions, such as the one I showed you, I assigned them all a numerical value, ranging between +3 and -3. In this kind of index system, positive numbers indicate various degrees of above average rainfall, with a +3 being the kind of highest degree of excessive rainfall, representing kind of floods in terrestrial zones, which would be highly unusual, to -3. Which is the highest degree of deficient rainfall, indicating basically no rainfall fell during that rainy season. 0, of course, is in the middle of that, and that just indicates regular rainfall conditions. Now you'll see I referred to that letter from 1870 from 1880, which refers to 1879 to 1880 rainy season. From looking at all the letters from that, which included some from the Church Missionary Society and some from the White Fathers, I assigned it a value of -2, which indicates that the 1879 to 80 season in Mpwapwa experienced a severe rainfall deficit. And then this was part of a pattern in which there are several seasons of very severe rainfall deficits in the late 1870s and mid 1880s. Now, what's the purpose of turning these rich descriptive documents, these which give lots of details? What's the value of turning them into this kind of much more bland, but I suppose quite pretty numerical scale, or at least pretty when you put it in a graph like this? Well, there's two things. One, it means that it converts the quality of descriptions into a numerical scale. And these kind of quantitative outputs can be treated in much the same way as the data that natural scientists have readily been collecting from tree rings, corals, and ice cores. Thus, they can actually be integrated with evidence from climate models, which is actually what I did with my climatologist colleagues at the University of Sussex in this article here, where we integrate it with 2 different types of climate model to try and make make time series of rainfall variability that incorporates evidence from the missionary archive and from climate models as well. So this incorporates evidence from in the region and from the atmosphere too. And the other thing you can do is you can start to fill in gaps in this map. This means you can enhance the accuracy of existing reconstructions, particularly where the reconstruction relies just on model data. We can use in-region descriptions, in-region data, rather than just model data, and therefore making this map look a little more equitable and methodologically sound. Essentially, in the absence of natural scientific attention, these kinds of data sets, the ones that have been created, can be used to begin to fill the gaps on this map, thereby enhancing our knowledge of regional rainfall regimes, how they have changed over time, and how global warming will affect them in the future. All right, thanks very much. I'll pass back over to you now, Laura, to introduce Brian.
Great. Thank you so much, Philip. That was really fascinating, especially given, I think what keeps me up at night often is the gaps in the archives. Working in the archival space, there's a lot of kind of colonial perspectives and biases and gaps that exist in the archives. So the idea that there can be gaps in the maps that archives fill instead of being kind of evidence of those gaps themselves is really exciting. Thank you so much. And also, if you wanted to, I can put a link to the chat if you wanted to look at the Church Missionary Society archive, or also we've digitized Church Missionary Society periodicals as well, which Philip used in his research. I'm going to put in a link into the chat. So if you wanted to request a free trial to look at those records for 4 weeks for free, you can do so. And next, I'm going to hand over to Brian. Brian Atwater extends earthquake and tsunami history into the recent geologic past, and the research has taken him abroad to Chile, Japan, Thailand, Indonesia, Oman, and the Caribbean. He's a scientist emeritus with the US Geological Survey and an affiliate professor at the University of Washington. Over to you, Brian.
Thank you, Laura. Let's see if we can advance the slide. There we go. Starting off with medieval Cambridge. This talk is also directed towards medieval time, and yet in the Caribbean, which immediately puts us before the time of the colonial office records that I'll nonetheless draw on just a bit. And I'll do that as a rank amateur in history, in that I'm an earth scientist. I am a historian in that sense, but looking farther back in time and using usually different kinds of archives than paper ones. And yet the Colonial Office records in this story inform the story a bit, and we'll end up actually with for Philip a coral archive, of climate that's preserved, not in a Cambridge building, but on shore on a Caribbean island, thanks to a tsunami that picked up coral heads and threw them on shore, and saved them from being attacked by the marine organisms that would have otherwise destroyed them. But the main character in some ways in this story is the Queen Conch, a Caribbean icon, and thanks to the Biodiversity Heritage Library, here an image of one of those from a 19th century artist. The Colonial Archive itself that we'll go to mentions conch. You can see that under where I've typed the word Anegada, the name of the island, that it says pyramids of conch shells left by the Caribe Indians. But this document itself has other purposes. The conch heaps are just decoration in a way for a much more sobering topic of the fate of enslaved Africans aboard a ship that ran aground on coral reefs in conch habitat just offshore this island. And this was after Britain had outlawed the slave trade, and people who came upon enslaved Africans who came on shore in British territory were nominally free. And yet some of these individuals were sold into slavery. So that was the reason that for the commissioners to inquire into the state and condition of those people. But there's much here that's incidental. I suppose this in some ways in Philip's case too, that he mentioned that the weather records there are almost incidental to what those missionaries were doing, but not quite. Okay, so the Queen Conch, what were the Indians doing with this in medieval time? The conch heaps there turn out to be from about the 11th century into probably the end of the 14th century. And the animal is there at left in a modern view. It's really wonderful with the eyes and everything. And then at right, what you can see is the way that the meat was extracted before machetes and axes got into the act. You took the sharp point of one conch shell and poked a hole through the other shell, and then slipped in a plant, a leaf that was sharp, sever the muscle from the shell and extract the meat. And you get about a day's worth of protein out of an individual shell. The island of Anegada we're going to, in the conch heaps that remain, probably has 2 million of these harvested shells. Here's a modern conch heap just offshore Anegada, and you can see the enormity of the heaps that result from the conch harvest. Now, these people look like they're about to feast on something other than conch. I think I see a rabbit there as well as the head of a pig. But you recognize them as Chaucer's pilgrims about to head off to Canterbury. And that in terms of archives, written records, would be the time of the tsunami we're going to look at. So it's about a century before Columbus. So naturally, it puts us before any written records from the Caribbean. So the archives we're going to deal with are geological archives. Now what's the reasoning behind, what's the purpose behind this work? My background is as a coastal geologist, and I ended up having seismologists as my clients. And it was that I moved to Seattle in 1985 at a time when seismologists were wondering whether a subduction zone here produces very big earthquakes and tsunamis. And I was one of the geologists who figured out that it has a history of doing so. And that history came to light mainly through coastal geology, but there's a component of this that's with documents in Japan. And so tsunamis are one of these hazards that are inherently international. The tsunami has no respect for international boundaries. And certainly that was the case with the 2004 Indian Ocean disaster. And the gap that Philip pointed to in the global South certainly pertains to efforts on Indian Ocean shores to figure out earthquake and tsunami hazards before the 2004 tsunami came along as a complete surprise. It turns out, okay, so after the tsunami, then you put up a sign like the tsunami hazard zone sign in Thailand that was designed in Oregon to deal with Cascadia hazards. But it turns out that the Indian Ocean shores have a rich history of tsunamis before 2004, the most recent of them in the 15th or 14th centuries. But these had to be uncovered by geology, and the geology was too late. So the idea is to get ahead of the game, to anticipate the tsunamis, to use the forewarnings that nature provides you in the way of the traces of tsunamis in the past. And just to carry it a little further with the Cascadia example, Philip mentioned tree rings, and they also play into testing a Japanese date for the most recent big earthquake in the Cascadia region. So Japanese documents showed that a tsunami of remote origin came ashore at the blue dots on the left-hand map. And tree rings showed that a pretty good coincidence in time with that orphan tsunami arrival, and that gave confidence that Cascadia really does have this kind of earthquake and tsunami hazard. There's something about geological dating where I, as a geologist, could say, well, sometime between 200 and 400 years ago, before Lewis and Clark, but after such and such, but I really don't know when it is, right? There was this very big earthquake and tsunami. Well, it doesn't communicate well a hazard to people if it's that indefinite. If you have a specific point in time where you intersect human history, then you're far better off in communicating the hazard. So this earthquake and tsunami was dated in Japan to the evening of the 26th of January, 1700 in North America, by the Japanese written records, and then the tree rings provided a test of that. Now, so that was my background at the time that the Indian Ocean tsunami hit, and I ended up with USAID support working on Indian Ocean shores with scientists from Indonesia, Thailand, Sri Lanka, and India. And there we were hunting for signs of pre-2004 tsunamis, so that on other parts of, for other tsunami sources in the Indian Ocean, geology could be used as a natural forewarning. But this arose also, this possibility for the Puerto Rico Trench, the deepest part of the Atlantic Ocean, where two tectonic plates come together, and there's no history, no written history of a tsunami of any size being generated in the Puerto Rico Trench since Columbus. But this island, Anegada, mentioned earlier, a low-lying island perched on the south rim of the Puerto Rico Trench, is a very good place to record a tsunami, and indeed it was overrun when while Chaucer was composing the Canterbury Tales. The main evidence, there's a lot of evidence on Anegada for this big flood from the sea. But in a way, the most graphic of it is with the corals that of the kind that Philip mentioned. But these are corals that are no longer where they started. They got ripped off from a coral reef that's north of the island in the direction of the Puerto Rico Trench, and they got scattered southward on shore, hundreds of meters inland. So each of these yellow dots represents a brain coral that got ripped off in the late in the 14th century. Here's what one of them looks like: 1.5 meters across, beautiful lifelike form, except where it's broken here. And its position on the landscape is in the right-hand image. There are some geologists for scale, and you see that same coral head out in a salt flat, and off in the distance, the coral reef. And then over the horizon would be the Puerto Rico Trench, the source of the tsunami that washed this thing ashore. Now, this is Hurricane Alley. So naturally you'd want to know, well, can't you just park those corals with hurricanes, and would they be themselves wonderful paleoclimatic records? Well, hurricanes of category 4 and even 5 have occurred in the past 50 or 60 years, run close to this island. Most recently, 2017, Hurricane Irma of category 5. And the effects were nothing like what you see here. All that down around that coral, all that the hurricanes managed to do was stir up some salt pond microbes and redistribute them as a coating on the land surface. This flood from the sea in medieval time was of a very different caliber. Well, there are, Philip mentioned modeling, and there are computer simulations of tsunamis as well. And here what you have plotted on a map of Anegada with the coral heads in yellow still are, I guess what we've plotted here are flow speeds, but the basic idea here is that you can ask, how big is does the earthquake have to be in the Puerto Rico Trench to make the tsunami able to deposit the coral heads on shore? And some of these coral heads are in places that are dry, not flooded in this simulation for an earthquake of merely magnitude 7.8, which is about the size of the recent Myanmar disaster earthquake. But if you jack it up a little bit more to a magnitude 8, you can flood the island pretty handily and flood all the sites of the coral heads. Well, this takes us back to that map with the shipwrecks and the conch heaps, because down in the lower right is the area of those prehistoric heaps. The modern heap offshore I showed you a picture of is I've labeled in purple. So we'll go into that eastern part of this island and look at those prehistoric heaps. And this is the area of that little square. And essentially the shoreline has moved since the tsunami ran across it, since the Indians were there piling up their discarding their shells on a beach. And so the shoreline is now shifted to the southwest, but you can see the line of the beach ridge there. And and then plotted in blue here and white are two kinds of conch heaps. One is with a flat, the main kind is with a flat top. And the other is in the southeast corner is a place where there was a cluster historically of convex heaps, and some of them are still convex today. Well, here's what the convex ones look like, and you can see that's me for scale on the. I'm about I don't know, shy of 2 meters tall. And you can see how it's nice and rising nice and tall, whereas this is one of the flat ones. And it even has limestone clasts on it that were part of the tsunami deposit washed in as the flow went clear across the island. But this conch heap just lost its head. It's thoroughly decapitated. Well, so that was our interpretation, but then we were given pause by, you use this to test earthquake size too, right? So the tsunami simulation for that magnitude 7.8 doesn't even succeed in flooding the heaps that are flat topped. And here it goes right across with the magnitude 8. Well, an alternative view is that all those flat topped heaps got taken down to make cement, essentially. And there's this account from a good observer of Anegada from the 1830s of that. And that gave pause even more, because this is a secondary source, but it's derived from the map that I showed you near the outset. And a person redrafting that map for the House of Commons proceeded to make the pyramids of conch shells separate. So we looked at that, and we looked at our separated flattened heaps and wondered, oh, did most of them get taken down to make
Brian,
lime? Yeah.
Sorry, just to kind of interrupt, but there's a few questions in the chat, so I was wondering whether you'd be kind of able to kind of bring it to a close so we can get to the questions.
Yeah, so this is the last slide.
Great, thank you.
Or second to last slide, but this gets you to the primary source that we started with, and there the heaps touch one another, which is probably from the cluster. So to the degree to which there's any integrity to that map, that's it. And the tie into climate is thanks to this tsunami. You've taken medieval climate records and the proxy records in the form of annually banded corals and preserved them. And here a group of paleoclimatologists is working with that preserved record, and at the right there's a digitized archive from it. Thanks for your patience.
Great. Thank you so much, Brian. That was really fascinating. And it's so interesting to hear about historical climate from the perspective of a scientist, as well as the perspective of someone who's trained within history and humanities originally. So yeah, thank you so much for those fascinating papers. There's a question for you, Philip, in the chat about whether you know of missionary accounts and whether they've been used for this type of climate analysis for the region of colonial Latin America. I know it's out of your region, but
it is out of my region. I can't draw. I wouldn't be able to draw cite some for you right now. though they would be relatively easy to find if they exist. I'm sure there is a wonderful article which is published in Climate of the Past, the same journal that I published my collaborative paper in, which is by a consortium led by a scholar called David Nash. And it is called Climate Indices, a Global State of the Art. And it was published in 2021, I think. And essentially, it gives you this, it was based it's up to date as of 2021. So, of course, it doesn't cite my research, which diverges from it in some ways. But it does basically cite and give reference to and describe all the kind of different methods that scholars from different regional specializations have, the ways that they've used mostly documentary sources to put their to put references to climate into kind of the same kind of numerical scale that I have. So if they do exist, I urge you to look for that article. I'll actually find it now, and I'll put a link to it on in the chat.
Great. Thank you so much, Philip. I think the next one is both of you. But if Brian, if you would kick off whilst Philip is looking for the link. And it's about oral stories. And Karen is wondering about the value of oral stories recorded in writing and whether these would be useful for documenting historical climates. I guess this could be either for you. So Brian, do you have any insights into that?
Personal experience. In 1988-89, I worked in the south of Chile in the region of the largest earthquake anybody knows about, the 1960 Chilean earthquake. And it produced a very big tsunami. And I was there to look at geology, but I needed to talk with people to find out what the earthquake and tsunami actually did. And the survival stories from people who went through the tsunami turned out to be more interesting than the geology. And we ended up publishing a collection of those stories in a way as guides to how people survived or didn't survive a tsunami. And it's been used by UNESCO in tsunami training. But that's an example of the value of oral accounts. You go out there and interview people.
Thank you. Do you have anything to add, Philip, to that?
Yeah, absolutely. This is something I'm very interested in. It's something I'm exploring now, and I think it might form the basis of a subsequent publication. In which case, I will be watch this space. Basically, is one of the things I actually pointed to in the article. We're very conscious that there's stages to kind of this process of trying to fill this map with data from regions of the global south, such as Eastern Africa. Now, the first thing, so I think we've quite successfully done that for this period of the 19th century, but we're also got to be conscious about the fact this might be written. These missionary documents were written in the region, but are they really of the region? These are a bunch of Europeans who are essentially proto-imperialists who directly contributed to the partition of the continent. Do they really represent is this really how in region is this kind of proxy that we've analyzed? So one of the ways that you might be able to kind of think about having a more of the region perspective on this is certainly with all sources and all traditions, particularly for the deeper past. Now, the paper that we did started in the late 1850s, which is the beginning of the textual records. But why can't we go further back? What would it look like if we incorporated all traditions which go much further back? There are challenges here. With oral traditions, they're often very difficult to place precisely in time. Particularly on the scale of seasons or years. But there are ways of reconciling this, perhaps by having a much more estimative time frame. Now, one of the things I didn't mention in my presentation is that there have been some kind of natural proxy research done in Eastern Africa, but they are rather than tree rings, corals, and I-scores, which often give you kind of an annual or seasonal kind of time frame. They're limnological records. They study lake sediments, which kind of tell you about fluctuations in rainfall over the course of decades or centuries. Now, what happens if you combine those with oral traditions? Can you get more precision on when you date oral traditions, which might refer to droughts, famines, floods, for example? And what happens if you, and in addition to that, does by having a cross section of these oral traditions from a kind of a climatically coherent zone, can you kind of give more kind of a sense of the severity or regional impact of a drier period, for example, that you might see in the limnological record? And these are questions that I'm still exploring the answers to, but and I'm very interested in trying to publish something on it moving forwards.
Great. Thank you so much. I realize we're on the hour. There's a couple more questions in the chat that are really fascinating, but there's questions about botanical records and indigenous practices and how these have been studied. But I feel like they're really, really big questions and I don't want to rush them in a minute. So if it's okay with you and Philip and Brian, is it okay to email you afterwards with those questions for those audience members? Thank you so much, everyone who kind of contributing those amazing questions, and we'll get them answered for you. We'll do our best. And thank you so much, everyone, for taking the time for Choice and for my kind of colleagues in marketing who've been working behind the scenes to help with this webinar, and Philip and Brian, thank you so much for those fascinating papers.
Thank you, Laura, as well.
Likewise, thank you.
Yeah, I'll just echo Laura and say thank you so much to Laura, Philip, and Brian for taking the time to speak with us today, and thank you to our attendees for your questions and your comments. I'd like to remind our viewers that we did record today's program, so be on the lookout for a follow-up email from Choice and ACRL with a link to the recording. Also, if you have a few minutes after the presentation to fill out a brief survey, we would really appreciate it. So thanks again to all of you out there for joining us. We hope you learned something new from the webinar and hope to see you again soon on another session.
Great, thank you. Bye.